Hello everyone and welcome to another episode of Advent of Code in Rust, the show where we solve Advent of Code challenges while we try to learn Rust. My name is Luciano.
Eugene.
And thank you everyone for following along. If you don't know what Advent of Code is, it is basically coding challenges that you can find in this website, adventofcode.com. They are published every year around Christmas time, 24 days before Christmas. That's why it's called Advent of Code. And you have a challenge every day. We are working for the ones of last year, so basically year 2020. And last time we completed exercise number 21 of 2020. So today we are going to be starting with exercise number 22. All our code is open source and you can find it here. We definitely accept PRs and comments and suggestions. If you look at our code, you'll probably realize that we are still noobs at Rust. So we can definitely use some help. Feel free to send us PRs and comments and critiques, whatever. Okay, Eugen, do you want to drive this one, right?
Yes, I do.
So
Also, I want to say hi to Tommaso because I see he's in the chat there.
Hey, hello, Tommaso. Thank you for joining today. Let me share your screen and then we can start looking at the exercise.
Thank you very much. All right, so today's exercise, number 22, is called Crab Combat, which I like, so I wanted to point that out. It sounds like either a video game or like a children's cartoon or something.
And by the way, it's perfect for Rust because the little crab is the Rust mascot.
Exactly. So there's a little story here. Long story short, a crab climbed aboard your raft and you challenge it to a game of combat. Combat is a card game, basically. So this means the input that we're going to get is going to look like this. Player 1 is going to get the cards 9, 2, 6, 3, and 1. Player 2 is going to get 5, 8, 4, 7, and 10, so on. So they're two evenly split decks of cards. And the way the game is played is each player plays the first deck in their card, like the one on the top, and whichever one is largest wins the round, which means the player who won it gets the two cards that were played. There's a little example here which shows how it works. So you have these two players' decks. Player 1 plays the first one, which is 9. Player 2 also plays the first card, which is 5. Player 1 wins the round, so the 9 and the 5 go into player 1's deck at the back in descending order. So the 9 is larger, so it goes in first, and then 5, because it's smaller, goes in second. The next round comes up. Same again, they play the first card they have in their deck, so that's a 2 and an 8, and player 2 wins this round. And again, in order, in greater than order, the 8 goes in first and the 2 goes in second. This game is played until one of the players has all of the cards in their deck, and then the score is calculated by going from the back of the deck to the top of the deck and multiplying it by the index, essentially. So the last card is multiplied by 1, the next to last is multiplied by 2, the next one's multiplied by 3, and so on and so forth until you reach the end of the deck. And that's the final score.
You can probably show the example at the end.
There is a calculation. There you go. I was trying to scroll through it. So essentially here, this player won, and this was their last card, which is multiplied by 1. This is the next to last, multiplied by 2. Previous one, 3. Previous one, 4, and so on and so forth. So essentially the first, or if you want to look at it another way, the first card is multiplied by the length of the, what you call it? Jesus. By the length of the deck. The next card is multiplied by the length of the deck minus 1. The next one minus 2, basically minus the index you're at, if that makes sense. So that's one way we can calculate it. So this is basically part 1. We have the puzzle answer, we have the setup here. So I would suggest that we start by parsing the input into a vector queue, so we can push and pop, basically, if that makes sense. So Let it do. Ah, Jesus, thank you.
Ooh, nice. You got a real Clippy.
I did get Clippy. It's gonna be very annoying, isn't it? Yes, it is. Okay, let's turn it off for a little bit.
I thought you did install Clippy.
No. I told you it's Laura Bananas.
Okay.
It had to be good.
We were not talking about the same Clippy. You probably need to restart your IDE.
Oh man. Jesus.
Yeah, let's do it. I mean, this is a nice...
Okay, cool. Oh man. Okay, sorry. I'm gonna quit and you'll get a new screen soon, hopefully. Okay.
This
it
is
going?
amazing.
Is it going now? Oh, it's stuck.
This will be in our YouTube picture.
Should be.
Let me remove this one.
Clippy
Try
for
to-
yeah, I got the wrong Clippy. Sorry, I kind of did this really quickly before the stream, so I just searched for Clippy. I found one, click install, and then so my bad. It's not. It's real Clippy, I suppose. It's bad Clippy. So let me know when you wanna reshare.
Did you stop sharing?
Okay,
Okay.
let's try again.
Now it disappeared.
It disappeared. Wonderful. So you should get a decent looking one now.
Yes.
Okay, so P1 is going to be vectq. Did it auto import for me? Ah, it did. Wonderful.
Yeah.
New,
You can
right?
do column new. Yes.
Okay, and we can do the same for player 2.
And probably want to make it mutable because...
You are correct. Can I call it P1Q and P2Q? Just to be
if you
cryptic
want,
to
yeah.
someone. Why is it unhappy with this? Type
Because you need to
I
give
need
it
to
a
say,
type.
yeah.
And I suppose we can use U8, maybe.
Yeah, I think so.
Because they seem... I mean, we can look at the input, but as far as I noticed, they were fairly small numbers.
What the hell? Sorry. New keyboard, new stuff. Jesus. I'm just gonna...
Yeah, do it again.
Just gonna do this again. Sorry. DQ. Ah, okay. I see now.
You mixed both things together.
It's fine. DQ of U8. Is it happy with this? Yes, U8. Go away. It's not happy with that.
Actually, Tommaso has an interesting suggestion that we could play with.
Let's see.
So he's suggesting to use a type.
Oh, sure.
So we could either create our own struct that wraps a vectq, or we can do a type alias.
I would
That is
do a
what you were
type
doing.
Q, right?
Or you can call it deck, or I don't know.
Oh yeah, deck. Makes sense. Okay.
And then you can do equal. No, wait. Do you want to do a struct or?
No, let's go with a.
Yeah, then let's do equal.
Yeah.
Equal vectq u8.
Okay. This should work. Sorry, I'm still not very happy.
And you need a semicolon there at the end.
We'll do it now, don't worry. Just very slow. Okay, and why is it not happy? Oh, because this one's misspelled. And so is
and
this
even
one.
that one, yes. Right.
Okay, cool.
Okay, now if I remember the input correctly, let's have a look.
Let's open it just to show it to everyone.
We basically have player 1, all the cards, then an empty line, all the cards for player 2.
Yeah.
So we could probably use that nice feature we used a few times that I think is called split ones.
Yep. So let me rename this to just input. So input split ones.
And then you can pass /n/n as a separator.
Wait. Keyboard.
Because that literally means empty line, right?
Yep. Wait. Not slash, it's /n.
Did you switch
So,
to
I'm not. There we
a
go.
Russian keyboard or something?
No. It's /n. And actually, I need two of
The
them, right?
quotes. Yeah, and you need
And single quotes.
no double
No,
quotes,
double quotes, because it's not
and you need /n.
correct.
Not doubles. Okay, yeah.
Yeah. Double
Now,
nearline.
if you unwrap that, you can assign it to a tuple that you can call, I don't know, P1 and P2, whatever you want to call it.
Yep. P1, P2, like
With
so, with rounds.
regular
Not,
parentheses, yes.
sorry. Get in there. Okay, P1, P2, semicolon. Okay, and then we can go.
And now you can remove the first line.
I think there was into iter, right?
You can do dot lines.
Just
Dot lines to get the lines.
Yep. Iter and then skip, or can you go skip directly? Okay, cool.
Skip one, yeah, and then you can do, I suppose we can map to integers.
Yeah, I think so. Where's pipe? Just gonna use this one. Sorry. I gotta use the correct shift key. So this is the input that we get, which is a string, and we can return I as. No, I can't do that.
No,
right?
you can do I.parse. And then you can do, before the parentheses, you can do column,
Yeah.
and then angular brackets U8.
Yep. Okay. And then for
And then you can do collect. And basically we could
to
collect
assign
everything
it.
into the deck. Yeah.
Yeah.
So we change basically P1Q and P2Q.
Q equals this. Let's see if it's actually happy. It's not.
Let's see why not. Cannot be
Our
built.
result. This...
Oh yeah, because you need to do unwrap there.
Okay, lovely.
Now you could avoid to do that vecdeq new and just declare it below.
I was gonna go do this. Do this. This stuff. Basically, what's happening now, in case you're wondering, is this keyboard is not a Mac keyboard. I am on a Mac. And it makes things very difficult.
We are gonna have fun.
It's gonna be very fun. Besides, I haven't done this in a few weeks. Okay, so this...
There is another suggestion from Tommaso that could be nice, more in terms of semantic, that if we also declare type card equal U8, then we can say parse card, which...
Yeah, that could work. It would be cleaner,
could be just a little bit more semantic, I guess.
Yep. So then let's declare this first, and then this is a vecdeq of card, right? Since we ew.
And then you can use it on parse, here, basically.
Right?
Yes.
Cool.
Okay, so now let's do a print or a DBG exclamation mark of P1Q and oh yeah, you can also do that.
No?
Good idea.
Is it not happy?
You can run test one.
Let's see.
Let's see if that makes sense.
So let's see if it's in the correct order. So 4, 25, 3. And these are 4, 25, 3. And player 2
the last one is 34.
34. Yes, 34. Yeah. And then 12, 6, 36. Okay, so it's correct.
Looks good. Okay, so now we can probably start to do the game logic.
Yep. So essentially, I'm going to comment this out if that's okay. Essentially, since we're going to be popping and pushing from them, We can probably go while length. Well, do vector queues have
I
length? They
think
do,
there is
right?
something like is empty. So we could probably do not is empty and not is empty.
Cool. That's correct. Super. Well, not that. And P2Q is empty, not. Sorry about that. Cool. So while this is going, we'll go. Let P1 cards. This is horrible. Is this okay? Just to
Now,
clarify.
yeah.
Pop front, basically. And the same thing for
Now
the back,
I
right?
cannot remember if it's pop front or pop back, but I
Pop
guess we
front,
can try.
because we want the first card. We can debug them, actually. Uh,
You can probably put a break there just for now.
yep,
Print the two and put a break.
yep. Just finding the keys. Sorry, man.
It's okay.
P, not Qs, sorry. Card. And we need this one as well, I think. And now we need to pass references to this, so it doesn't consume them. Wonderful. So let's run the test.
Okay, 4 and 12.
Which
So
is
you're probably correct.
4,
yeah.
and
12.
presumably 12. Okay, so that's correct. Cool.
Nice.
Okay, and it's a sum, so this needs to be unwrapped as well.
Yes, good point.
Okay, so
And we are sure that there is one because that's the condition in our while loop.
there's one thing they never said in the README. What happens if they're equal?
I think all the cards are different, but it's a good question.
It's, I mean, I think it's. We'll see. Hopefully, we don't run into this. Okay, so essentially, if P1 card is larger than P2 card,
Basically, player 1 is winning.
yep. P1Q push back. P1 card, and then can you push 2? No, you can't push 2. Boo. Okay, let's just do 2 lines for now. P2 card. And I know I need semicolons, sorry. Else, we'll do the same stuff.
Yep. And in this case, you need to push in swapped
In-
order, right?
Exactly. And to the other queue.
And to the other queue, exactly.
I know this isn't the most elegant way, but you know.
I was
it's a
thinking
way.
we could create a reference to a winner deck, but then you need to sort the two cards, so probably this is good enough. It's probably, yeah.
I think simpler for now. So in theory, this should this shouldn't be an infinite loop. Let's see. I'm gonna run the test and I'm gonna output the 2 queues at the end. Fair enough?
Yes. And one should be full and the other one empty.
Yep, player 2 queue is empty. Player 1 queue has
is everything you
a
saw
bunch of
before.
cards in it. Cool. So this is actually a fairly easy exercise. I like it. Okay, I'm gonna let the debugs in for now, just in case we wanna mess with them later. We should calculate this number, right? Which is basically whichever one of those queues isn't empty.
Yep. Oh, I understand maybe now what Tommaso is suggesting.
Oh, what is the suggestion?
Let winner loop. So are you suggesting that basically our loop returns a winner?
Yeah. He is saying that a loop can return a variable. So essentially, we do the logic of which one has length. Actually, if one of them doesn't have length, you return the other. That sounds very cool. I had no idea about this feature, so that's lovely.
Yeah, I was thinking to do a ref. The only thing is that then we'll need to have a break condition, or can we do the same?
We can use these. So loop like this, and then if this one, sorry, I'm just gonna move these as they are now.
And you just return at that point.
Exactly. I return whichever one, come on.
Fails the check,
Exactly. If this guy is empty, oh man.
But let's
player to queue.
Can we do it at the top?
Yes, we can. I'll move them in a second.
I don't know why it feels safer. I might not make any difference, to be honest.
Yeah, you're probably right.
I think the only difference is that if one deck could be empty at the beginning, this one will be a little bit safer.
Yep. But... Oh, I also need to return. And because this isn't the last line, it needs a semicolon. P2Q, why are you not happy with this?
What if you return a reference?
No, expected U size. Why is it expecting a U size? I don't want a U size. I want a deck. Sorry.
Oh, you need to break, not return. Interesting.
Ah.
Makes sense, because, yeah.
It's...
And
man, again,
do you need the semicolon?
Maybe
okay,
not.
That's fine.
No, I don't need the semicolon.
Okay, perfect. So
it's not happy with
there you need a semicolon, because otherwise it's returning the winner. Yeah.
It's a value declaration now. Sorry, I forgot. Okay, so then we just need to go winner iter or into iter.
Yes, iter I think is the same. Then you can probably do rev.enumerate.
But we don't need to rev, or we can rev.
No, wait, iter doesn't take any
Yeah, you're right. Rev and
enumerate. And now we can do map, and we calculate every single multiplication.
Yeah, or we could just reduce, I suppose. Not reduce.
But then we can do sum at the end. Like if here we map every single value.
So this is a number. Wait.
Here you have an index and a number. And we'll just need to multiply.
Basically, and we return I times n.
But we need to do I plus 1, I think, right? Because
we have zeros.
Otherwise we'll be 0.
You're right.
Put parentheses around I plus 1.
Yeah, correct. Whoop, wrong keys. Apologies.
And then at the end you can do dot sum, I think. And that should be our... Oh yeah, now a U8 is not going to be enough. So probably we also need to do as...
No, because why is it unhappy? Closure is expected to take a single...
Oh, you need parentheses.
Sorry. Why is this happening?
And now it's probably complaining that U8 is too small. So put as...
No, it was saying it's... Trade bounds, U size, sum of U8. Okay, so this needs to be as U32, probably more than enough?
Yes, and N also as U32, because N is U8 right now.
Yep, correct. No, N is U size. Casting U8 as U32 is not valid.
No, wait, I is U size.
You're right. So, this... Yep, sorry.
Okay, why it doesn't like that?
Because it's a reference. Let me dereference it. Yeah, okay, and now...
Y.sum doesn't work. Sum U32 is not satisfied.
usize as sum.
Oh, because we are returning a reference, are we?
I don't think so. Doesn't map return a new thing, and doesn't sum also return anything?
Okay, do a into iter there,
Yeah.
just for a second. I mean, we're not gonna use this winner anymore after this, so it's fine.
So this,
Now n is directly a u8,
yep, and I is a usize.
which is fine. So if we convert both to u34, that
32.
u32, that should work, right?
I as u32 and n as u32.
Okay, now why Sam is complaining? Oh, do we still have that other return at the end?
No, I commented it out.
Okay.
What are we saying we're returning here? A usize.
Oh, okay, that's why. Okay, good catch. You can either
Should
do
I?
as new sides or change the return type,
I
whatever you
would
prefer.
change the return type, I suppose.
Fair enough.
Should be happy. Yeah. Now I'm not sure if it needs to be u32.
I mean, it looks small enough, so that should be good.
Yeah. Okay, it actually passed.
Nice.
Beautiful.
Works.
So let's clean up some of the unnecessary comments. What else? This guy. It's actually not too bad, I think. It's not great either, but it works.
Yeah, one thing that we could do is just to make it a little bit more idiomatic, we could create our proper type rather than just a type alias. We create a deck type, and then in that type we implement from string.
So it knows how to parse it.
And then at that point we don't need to do that lines.skip1.map 2 times. You just do .parse.
Yeah, fair enough. Okay, let's do that. So card can stay as a type alias, but deck, we still make it a type.
No, you need to do struct
then
deck. And you need to
bracket it up.
Yeah, you can either give it a name or you can just do 0. So there are 2 ways you can do a struct. You can do a struct that wraps a tuple.
Okay, this is the only one that I'm aware of so far. So
Or
do share.
Or that creates like proper fields with names. So if you just want to wrap a tuple, you do deck parenthesis and the type. So for instance, you can do vecdeq card.
Okay. Oh yeah,
And you can remove the curly braces. And when you do that, the way to access the actual vecdeq is by doing .0, because that's the only attributes that we have basically.
Yeah.
So we could go this way for simplicity for now.
Okay. But then we also need to implement parse for this one, right? So we can do an impl of deck, right?
So to implement parse, we need to implement from str, which we can search in our previous examples, I think.
Let's see if there's
give
any.
me a second to find it.
It's not here. We've used it, but I don't know where.
It's search for uppercase from str.
Sorry, this is too. No.
Oh, where is it search?
These are the benches. Let me
close the SVGs. Yeah.
Let me just ask it to find here from str. Okay. There we go. I'm actually going to copy the entire implementation.
Yeah,
and then
perfect.
we can take a look.
And now you can call it for deck, exactly.
Okay.
And now inside here, what we need to return is a new deck.
vecdq. We can basically copy this bit, right, to the very end.
Yeah, exactly.
Did I not delete these lines? Oh, and you need to return an OK of this, I think.
Yeah, because that can fail in theory. Like you could implement a parser that fails.
Well,
But you don't have to return a vecdq, you need to wrap it in a new deck as well.
So
let's do a vecdq first, just for simplicity.
So let's mute. We don't need it mutable.
You don't need it mutable, yeah, correct.
So Q. If I can type. Okay, we make a new vecdq, right?
Mm-hmm.
Which needs a type.
Yes.
Can we just make a new deck? No, because we're inside the deck.
No, you can do vecdq of card.
Mm-hmm.
Deck is wrapping all of that.
Yep.
And we'll do it later.
Okay.
Okay.
Do we need to make it a new?
Actually, you don't need to do a new. You just need to do, instead of lines, you can do s.lines, because now our input is called s.
Okay.
And that should be it. And now
we
we return of deck of q.
Like this.
Yes. And that's
Why is it unhappy? Because I misspelled this. Sorry. From str.
Oh, you need to import some
import
std.
It. Yeah.
Save it again.
If I save.
Perfect.
It's okay.
Okay, now you can do p1.parse.unwrap there on the right side.
Sorry.
And magically it's gonna understand what to do.
Wrap.
And similarly for the
just
other.
Copy this over. Yay! But now we need .0.
.0, yeah.
Alternatively, we could probably implement that. Because this is a bit dirty.
Or we could call it cards. Like rather than using a tuple, we use a proper named list of attributes.
Yeah.
So using the curly braces and call it cards if you prefer.
Yep. That's cards.
No, you need the column.
Column, I don't remember. And this doesn't need that. Why is it unhappy with this?
And it doesn't need the semicolon,
because it's a struct declaration.
And now deck, you need to pass curly braces cards. So maybe you can call cards rather than Q, so you don't need to repeat.
You're right. Copy, paste. It's not happy. Oh, because I'm also...
Oh yeah, you don't need a parenthesis. Yeah.
Sorry.
Perfect.
Okay, that's now happy, and these are not going to be of 0.
But it's going to be dot cards.
Yeah. Not... Hey.
Which is maybe a little bit more readable. Now that pop front and pop front there might still be an happy because... Oh no, we made it mutable, so that should be fine. Okay.
Yep. We could also make this nicer, I guess. Okay. Let's see if it's still... No, this isn't happy. Oh, because we
now
don't
it's
have
winner dot cards.
Does it still run? I wonder. It does.
Yes, nice.
Lovely.
Okay, so this is a little bit better. For some reason, your formatter is not working, but that's fine.
I don't know why. It's a new install. You could run it from a terminal, right? Cargo FM Cargo FMT. Does it? No. Yeah. I don't remember if it
I think
enhances.
so, but I don't remember exactly if you need any extra parameter.
I think FMT is from Go, because Go's. Hang on. It has formatted it now. I don't know why it's not doing it automatically, but anyway, I can run it in a terminal.
Nice.
So
Okay. Now I don't know if we want to start looking at part 2 that seemed a little bit complicated, or
should.
Tommaso is suggesting this one that could be interesting to try. You can also create a struct game that implements iter. And then I suppose we'll need to decide what do we emit. So do we iterate over turns of the game? But then what do we return? Like we'll need to return something at the end of the game. So I'm not really sure how that might look like.
Also,
Bless you.
apologies. No, that was unexpected. I'm not sure what that game struct would do. As in, right now we have the loop, which
I
is
suppose
basically
one thing we could do is that the game struct contains all the state and you just iterate until it finishes.
so you
then,
just go game next, something like that.
Yeah, you do while next or I don't know, collect, whatever it is.
Okay.
And then at the end, in looking at the state of the game, you can probably get the winner.
Tell you what.
Or you can get the score, whatever. Maybe the game can do everything, but it feels a little bit like a stretch right now.
Before we do any of that, I will commit.
Yes.
Y 2020 exercise 22, right?
Part
Solution.
1.
Oh yeah, part 1, correct. Felt like I was forgetting something. What? Oh, don't tell me you didn't push.
Probably never configured your Git there.
I think I did. Hang on. Oh no. So
you might need to do the RSA key, the SSH key, and so on.
No, I did that. So fetch. Hang on, I'm doing this in an actual terminal. No, I have. Okay, we have one different commit each. That's the problem, actually.
Do a git pull.
Yep. Merging. Okay, this is going to give us an extra commit, but it's fine. Okay. Okay, I pushed now. So if we go into this thing, sorry for doing it in a different terminal, but this one's showing me weird. Okay, it's all up to date. Apologies. We're done. We're good.
Okay, perfect. So
I would suggest we look at part 2.
Yeah, let's start to look at part 2. I don't think we're going to be able to finish it, but maybe we can at least understand what it's asking for.
We have a bit of time, so let's see. So, we lost to the crab. So we challenged the crab to a game of recursive combat. Now, I will admit we did take a little look at this before, but we didn't quite get everything, so we're going to do this together. So, it plays with the same 2 decks, and there's a series of rounds with a few changes. So, before either player deals a card, if there was a previous round in this game that had exactly the same cards in the same order, so specifically if player 1 plays a 9 and player 2 plays a 5, if they had played the same cards before, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. This I didn't understand.
I think we don't need to keep track of multiple games, just one game if the round repeats itself.
Okay. Okay, so
Now, a
if
question that I have there is, what does it mean for the round to repeat itself? Is it enough to see the same two cards? Or also the dex needs to be the same when we see the same two cards? We can probably figure it out from the examples later.
yes, it says in the player's decks. So this means, is there an example?
I hope so.
Yes, there is an example. But let's read because there's a few more rules here, so I guess the example contains all of them. What I'm understanding from this is that if the decks return to a state that they were in previously, and this is to prevent recursion, yes. So if I have 953 player 1 and whatever 386 player 2, if that has occurred before, it's going to automatically give it to player 1, regardless of who was supposed to win. Which is kind of silly. It should end in the opposite of victory, just to avoid recursion. But anyway, what I'm getting is like, yeah, the same. We need to keep track of the deck state, basically. Not the cards played, but the decks as they looked through each round. So, like, I guess it's a very big VecDQ of hands, basically.
Or
Right.
yeah, we'll need to somehow index every single round, the state of every single round, and then if we see it again, basically, that
Okay,
means that
so
yeah.
if there was a previous round, we do that. If there wasn't, this round's cards must be in a new configuration. The players begin the round by each drawing the top card of their deck as normal. Okay, cool. So, fair enough. If both players have at least as many cards remaining in their deck as the value of the card they just drew, the winner of the round is determined by playing a new game of recursive combat. Okay.
Okay, that's where the recursion comes from.
Yeah, I was wondering. So, just to clarify and to make sure that I understood it, if I have three cards in my deck, or four cards in my deck rather, and I draw a three, my deck will now have three cards and I drew a three, which means we go into a new game of recursive combat. Otherwise, at least one player must not have enough cards left in their deck to recurse.
The winner of the round is the player with the higher value card.
I don't understand. When do you not have enough cards left to recurse? Oh, as in when you...
Probably you have like 3 cards left and you are picking up a 4.
But wait, what does the... If players have at least as many cards remaining in... as the value of the card they just drew. Okay. Okay, so if I
basically,
play a 3... Go ahead.
yeah, if you just play a 3 and I play a 4 and we both have more than 4 cards, I think. Actually, you have more than 3 cards, I have more than 4 cards, maybe. Then it's not obvious who wins the round. We need to play a recursive round.
Yeah, I get it. But if I had less cards, then it would be a win of the player with the largest card. Okay.
Yes.
Yeah, I don't think we'll have enough time to finish it today, I agree. So, as in regular combat, the winner of the round, even if they won the round by winning a sub-game, takes the 2 cards dealt at the beginning of the round and places them on the bottom of their own deck. Okay, so this happens after the recursion, so that the winner's card is above the other card. Oh. So this time they're not ordered by value. They're ordered by the winner's card comes in first.
Okay.
If collecting cards by winning, sorry, the round causes a player to have all the cards, they win and the game ends. Here's an example of a small game that would loop forever without the infinite game prevention rule.
Okay, I'm not understanding what happens after a first recursive round. Do you come back to the same configuration as before?
Yeah.
Or you continue with whatever is left in each deck?
So in recursive, where was it? The winner of a round, even if they won by winning a sub game, so it doesn't matter who wins it. It could be like a recursive game that was won, or the actual cards being dealt right now. The winner takes the two cards dealt at the beginning of the round. So essentially, at every round, you deal the two cards. You play a card, the crab plays a card. And if you can play a recursive game, you do so with the cards left in the deck. And then whoever wins
Yeah,
takes the
let's have
two
a look
cards.
maybe at the example below. There is like an example game. Maybe that will make more sense.
Maybe, yeah.
So we know. Wait.
Round one. So this is the first round of the first game. So we have
Okay.
9, 2, 6, 3, 1, blah, blah, blah. So this is simple. Player 1 wins round 1 because 9 is bigger than 5.
Because 1, 2, 3, 4, 5. Yes, okay.
Oh no, wait. 1, 2, 3, 4, 5. Why does player 1 win? Because player 2.
I think because both need to have a number that is lower than the number of cards that they have left in their own decks. So here player 1 has 9 and it has less than 9 cards because it has 5.
Yeah, I get it. So this guy played 5, but he played the 5. So he would only have 4 cards, so you can't play a recursive game. If this
But
card
also
would have
they
been
need
a
to
4.
be both in that situation or not.
No,
If both
only
players have at least as many cards remaining in their decks as the value of the cards they just drew. So both of them needs to have played a value that
Yeah, but
is
if both
lower than
have
the number of cards that they have left.
if both of them have as many, so both in the case, sorry, going back to this example, in the case of the 9 and the 5, this player must have had 9 cards left, and this one must have had 5. Both
Exactly,
true
yes.
to go into
Both true to
recursion.
go into recursive.
Okay.
So we don't go into recursive. Round 2.
Okay, 2 and an 8.
2 and an
Easy.
8. Same reason we don't go into recursion, and
6
player
and
2
4.
wins.
Yeah.
Then 6 and 4,
Player
we
1 wins with the
still
6.
don't go in recursion, and 1 wins. 3
3
and 7, still no recursion. 1 and 10, still no recursion. 9 and 8, still no recursion. 5 and 2,
still no
still no
recursion.
recursion. 6 and 7, still no recursion. 4 and 3, round 9. Here we have recursion.
Why? So player 1 plays 4, and they have 4 cards.
Yeah, and player 2 plays 3,
but they have
and they
4
have
cards.
more, but they have more than 3 cards. Doesn't have to be exactly the same, it needs to be more.
Okay. Okay, so they go into the game with 9852. Okay, so the cards that they have not played.
Okay. And they continue until one of the two wins, but I'm curious to see what happens when they go back to game 1.
So this is it. Player 2 wins round 6 of game 2. The winner of game 2 is player 2. Wonderful. Back to game 1.
And
Player
back to
2.
game 1 with which state? It's
Player
the same
2.
state as before, right?
Yes.
9852 and 10176.
9852, which is this, and 10176. Player 1 played the bigger cards, but player 2 won the recursive game. So player 2 gets the 3 and the 4. Yeah, they get both the cards. The card they played came in first, and the other player's card came in second because they won the sub game. I'm really, really hoping this makes sense for the people watching
Yeah.
us. Oh, there are some comments there.
It seems like ought
I
to
know.
resolve 3 and 4. Creating a branch of the game.
Yeah.
Yeah.
Yeah, it's basically a branch of resolving what cards you would have had left. And then based on that win, you alter what the round would have played like normally.
Yeah,
Okay,
maybe
so
we can think of a possible solution and close the episode here, and then trying to implement it next time.
yeah, that sounds fair.
But I
Do we
suppose
wanna...
one way to do it would be to have a generic function that can play a game given a current configuration,
Yep. Correct.
and then it returns the cards. Actually, no, it doesn't matter. It just returns the winner of the two
Returns the
players.
winner. And internally, that function also needs to keep track of
the duplicates.
Yeah, of the states of decks before. That sounds fairly memory intensive, by the way.
And that same function needs to be recursive because, of course, to determine one game, you might have to recurse.
Yeah, it needs to be able to call itself. Essentially, I see the entry point to this game as being we parse the inputs into two decks, which need to be sliceable, essentially, or clonable at least.
Definitely clonable because I imagine that when you enter a sub game, you clone everything because you don't want to lose the previous state.
Exactly. I would assume it as getting some values as its arguments rather than references or anything. It's like, here's your decks, which you can do whatever you want with. And when it calls itself deeper inside, it just gives it its decks. And then it can keep track of stuff internally, and it can push and pop and do whatever it needs. Makes sense like that.
Yeah, so it's more of an exercise of recursion, and I think we cannot avoid to clone stuff in this particular case. So it kind of makes it easier, considering that we are doing this in Rust.
Yeah.
Because, of course, if we were using references and recursion, we know it's not an easy thing to do in Rust.
No.
But because we keep copying, we just recurse normally.
Yeah, it makes it easier. Well, still not easy, but easier. Somewhat better.
I suppose the base case is when you can return immediately.
How do we even... Do we want to
But
take
in
a
any case,
stab?
you need to have a loop. So in the loop, you might call recursively.
Do we want to take a stab at defining this function?
Yes.
It's going to be called game. Probably with a lowercase g. Right? Deck 1, deck 2. Which are going to be deck. This is probably too high in the code. Sorry. I'll do it after the declaration of deck, just to keep it a bit cleaner. So this would also need a state. Oh, and what does it return?
Yeah, that's interesting. Do we return 0 or 1, depending on who is winning? Because when you recurse, you need to know who was the winner.
What data do we need out of this? Like, what do we need to return? What is the winning player's score?
Oh, so we still need to know the final deck of the winner.
But on the first of the first game, the top level game, basically.
So we
top
could
level
actually
game.
create two functions. One that is the
Yep.
top level
Function
game, and then game recursive, something like that.
Yep. And this would be like so. So this would return a deck. No.
That would return
A deck. And this would return usize, just to return a 1 or a 2. Come on. 1.
Or I suppose, yeah, what Thomas is suggesting makes sense. We can do it still in one single function.
Not tuple. Yeah.
Yeah, that could be one way of doing it.
That's true.
Yeah, probably a little bit more elegant. Otherwise, we end up having a little bit of duplication between the two functions,
will
I
indeed.
suppose.
So usize and deck. Usize them.
Yeah. We could
Jesus.
probably do an enum with player 1 and player 2, but I mean, let's leave it for later.
Yep. Now this isn't valid, but this would be the signature of the thing. And then in here, it needs to keep state of the two decks, which are going to need to be, we need different structs for this, or type aliases.
Oh, you mean the history? You need to...
Vec the queue of deck. Right,
does it need to be a vec the queue?
Well, it can be just a vector, I suppose, because we're not going to be popping.
So basically what we want to see is if at any given point in time we see the same two decks for player 1 and player 2. Yep. So game history is a sequence of player 1 and player 2 decks, but also needs to be searchable in a quick way.
I was thinking of keeping a history for each of the... but we need both of them. Okay, so we can make this a tuple of two decks then, right?
Mm-hmm. So what we could do, it could be a set, an hash set.
Yeah.
Because we are only using U8, and U8 are hashable.
Correct. And I need to import it.
You need to import that.
6, import that guy. Happy now? Yes, it is. Okay, so history. Let history is gonna be game history.
I was expecting. I think at some point it's gonna tell us to derive hash in deck, but for now doesn't matter.
Can I pass it the two decks here as a tuple?
No, I think you need to do dot insert.
Okay. But
in another
I
line.
need to do it in a new line. Okay. Insert this. Oops. Apologies.
And at this point, you can do a to-do exclamation mark at the end to make it stop complaining.
Wait. Stop complaining. Where?
For that usides deck, because we are not returning usides and deck.
Here? At the end, I'm not.
No. Sorry. Line 29, create a new line below. And do
unimplemented.
Either unimplemented or to-do with...
Yeah. Now, why is it not happy with the insert, though? Exists.
It is up, or not?
Deck EQ? Because it doesn't know how to...
But is an error, or is just...
I don't know, it's... Let's see if it runs, okay? Let's try to run part 1 and see if it actually compiles. No.
Okay.
Method cannot
Perfect. I was expecting that. So basically we need to do derive in the struct.
Wait, this thing. Deck.
Line 7.
Yep.
7. There you need
derive.
to do hashtag.
Hashtag derive, was it?
Hashtag square brackets.
Wait. There we go.
Open square bracket. And then derive open parenthesis.
Mm-hmm.
And then uppercase hash.
Yep, and EQ.
And EQ. And it might also need partial EQ, but let's see.
Partial EQ is not implemented for deck.
Yeah,
Let's
do
see.
also partial EQ.
Okay.
And that now might be happy with it.
Cannot borrow.
Oh, it needs
history
to
as
be
mutable.
mutable or not?
Yes, but why is this?
Okay, now it's happy.
Cool. I think this is committable.
It will just
can-
complain that we are never using that game
Yeah.
function, but that's fine.
Exactly. Do actual game. I think that's quite useful.
But essentially now with the set, we can easily compare if we
Yep.
end up in the same state as before.
Mm-hmm. Work in progress. Push. Yay. Okay. I think
Nice.
this is okay for now. So I'll stop sharing.
Okay, then I'm gonna do the closing. So, thank you everyone for staying with us until now. I hope this was somewhat entertaining and interesting. We definitely learned a bunch of interesting things like being able to return in a loop and use that return value from the break in a loop. So, thank you, Tommaso, for suggesting that. Anyway, we are going to be posting this video on YouTube, so definitely check our YouTube channel out, and you can find the link on the Twitch description. If you're watching from YouTube in the future, of course, we are live streaming on Twitch, so make sure to check out our Twitch channel, and if you want to follow us there, we'll be appreciating your support in the next live stream. Other than that, a reminder that we accept PRs. This is our repository with our current solutions. Definitely, you are more than welcome to submit PRs, comments, issues, whatever. Everything that helps us to learn Rust is more than well accepted. And that's pretty much it. We'll be seeing you in the next stream. And thanks everyone for following along.
Thank
Bye-bye.
you all. Have a good one. Oh, and raid someone maybe if we can.
Oh, yeah. Let's see if there is anyone ready to be raided. Yes, we have somebody building a programming language in Rust. Let's do that. See you, everyone. 3 seconds.